Hey guys, what's going on? RIP headphone users, my bad. And welcome to this Java series. And I'm super hyped, and I think it's because I took too much pre-workout. Alright, so this is sort of my first attempt at making a series ever, so let me explain a little bit what AMTS is. AMTS is an abbreviation for American Martial Training Systems.
What the heck? What does martial training have to do with coding?
Well, let me tell you what it has to do with coding. We believe we have sort of a holistic philosophy. We want a holistic view of life and being prepared. And so in this day and age of computers and technology where, everything's a computer, I believe it is important to understand how computers work. And we have sort of this hacker mindset where I want to know how things work so that I cannot be manipulated by them. And if you're a bad person, you can manipulate other people with them that don't know how they work. So yeah, I think it's important to understand how things work, and one of the best ways to do that is to build it yourself. Or in my case, you try to figure something out, you break it in the process, and then in the process of trying to fix it, you sort of learn how it works. I do that all the time. It works out so far, so. So why make another Java series?
Yeah, why? There's like a million of them already on YouTube.
And by the way, that's exactly how I imagine anyone viewing this video would sound. Sorry. Well, I remember when I was watching YouTube videos, I was sort of stuck in between this beginner phase and intermediate phase where I could understand the concept, I can understand what to do with it. I understood the example, and I understand how to use things within the context of the example. But after that, after I left the video, it's like, okay, what do I do with this? And that's really what I want to address in this series. And I want to do that by doing actual little projects. And I got this idea from a book that I had called Beginning C++ Through Game Programming by Michael Dawson. It's a pretty neat book. He not only does he show you the basics, but he takes you through how to make hangman and tic-tac-toe and things like that. And I'll put the link in the description for this book if you're interested. Right. So my sort of plan is to have sort of, I want to go into depth a little bit and like theory, if you can imagine me doing finger quotes, theory. As well as the concepts and example, and then once we build enough concepts, we can do sort of a little project. And I'm going to try and keep the videos relatively short, much shorter than this one. This is just sort of an introduction to the series. So there's that. Now, and let's talk environment. If you are here to learn how to set up an IDE, I will not be showing you because I don't use IDEs. If you talk to anyone in the computer science field, and anyone that's a software developer, they will tell you two things: learn how to use a debugger, and learn how to use your tools extremely well, and you'll be as productive as anyone else. So I use Vim as my text editor, and I use the terminal to compile and execute my programs. If you'll notice, I am not on Windows, I am not on Mac, I am in fact on Linux. More specifically, Arch Linux. Linux has this great philosophy of do one thing and do it well. And what this allows you to do is string programs together in ways that the original developer would never even imagine, right? And sort of a graphical user interfaces or GUIs, they're just a pain in the butt to program, in my opinion, anyway. And it really limits what the user can do, which could be a good thing. If you're assuming someone's stupid, you do want to limit what they can and cannot do, because obviously people don't know how to use a terminal. So if you're in Windows, RIP, I'm sorry for you. No, but if you're in Windows, you can use the command prompt if you want to follow what I'm doing. The commands for compiling and executing will be exactly the same. You might have to use Notepad or Sublime or something. Otherwise, I assume you're competent enough to go download Java and go download an IDE. You just go to the download page, download Java, double-click the icon, press next a few times, let it install, and it's done. Same thing with Eclipse or whatever IDE you want to use, JGrasp. You go to the site, you download it, you press next a few times, and it's installed. You go to File, New Project, File, New Class, name the class, name the project, and all that stuff, and you're good to go. If you still need help with that, I'm sorry that I called you stupid. Don't take it personally. I'm just stupid. So, really, I'm just lazy and stupid. I don't know. But I'll put a link in the description of someone else making the video because quite frankly, I just didn't feel like doing it. And so I won't be doing it. Alright, so the sooner you accept that text is the universal interface, the better off you will be. It's just a whole lot easier to debug, and you don't have to focus on the GUI programming. You can focus on the functionality of the project. And that's why we get awesome, nerdy games like Dwarf Fortress, where there is no GUI, but the mechanics of that game is insane. If you can figure out how to play it, of course. Most people only scratch the surface. I've only scratched the surface. But yeah. So now, let's talk about Java. Why do people use Java? Well, one of the major benefits of Java is that it is cross-platform. Now, what does that mean? That means I write the code once, and any, machine that can run a Java virtual machine, you can run your Java code. Assuming the versions are somewhat related, and you're not using deprecated stuff and like that. Things like that. The backwards compatibility, that's a different issue. But the idea is you write your code once and it'll work on anything. How do they do this? And what is a platform? Well, platform generally is a combination of your processor and your operating system. So what happens is your processors are all different. The different models have different circuitry, and the circuitry defines the different sets of instructions that is available to the processor, right? So this Intel processor that's probably in my, well, I don't think this exact one's in my laptop, but is completely different from this ARM processor. This runs in your phone. They're not even remotely the same. The architectures are actually entirely different. And this is some old guy pointing to hopefully a really old processor. This is probably completely different from these two. Or not completely different, but if you're writing C++ or something that compiles down to binary, and you compile it for this platform, it will not work on here or here. And so Java kind of overcomes that, and it's pretty nice because you don't have to macro the crap out of your code saying if it's Linux then do this, or if it's this, if it's Windows do this. So that's also, like I said, I'm on Linux, so if I'm using system calls for Linux, obviously Linux is different from Windows. I can't use that same code on Windows because the system calls are just different. They just don't exist. And so Java just abstracts that away. Right. And so it does that by using this Java virtual machine. So one of the things when you go to download your Java, one of the things you download is a Java virtual machine for your specific platform. So this Java virtual machine understands that you are on Windows with an Intel processor, or you're on Linux with an AMD processor. And so what happens is you write your Java code, right? This is your Java code. It gets compiled with the Java compiler into this bytecode. Now, bytecode is sort of an intermediate stage between your code and the machine code. And this bytecode is understood by the Java virtual machine. And the Java virtual machine... Whoa. Whoops, rumbled too much. Anyways, so the Java virtual machine will interpret this code, this bytecode, and execute it accordingly for your given platform. And so that's how it does that. Another good thing for sort of beginners is sort of a bittersweet thing for me, but it's okay for beginners, I guess, is that this guy, I don't know his name, but he's the creator of Java, as you can tell with the logo next to his face. He pretty much sat down with whoever else created Java, and they said, look, we're smarter than you. We're going to put features in our language such that you can't make stupid mistakes that programmers have made in the past. And one off the top of my head is buffer overflow. We can talk more about that when we talk about arrays and things like that, if we ever talk about memory. Or you can just Google it. It's a serious security risk that has done some damage in the past. So, he sets out, he takes certain things and he fixes it in the language so that you can't mess it up. And that's good for a beginner, I guess, because you don't have to worry about it, right? But you also don't learn about it, right? So, for example, in Java, or in C++, we have pointers and references, right? And in Java, they are there, but you as a developer do not have access to them. The Java virtual machine handles all of that for you. The language handles it for you. That's kind of bittersweet for me because you won't make the mistakes, and then when you go to write C++ code, you can be like, what the hell is this? Same thing with memory management. Java has a garbage collection, and it's automatic memory management so that you, the developer, don't have to worry about it. Which is great, I guess, for a developer or for a beginner. Of course, the garbage collection. Basically, when something isn't being used in memory, it just says, hey, this isn't being used by anything, so let's free up the memory so that we can put something else there later. And of course, it's great until the garbage collection crashes, and then you have ton of memory leaks in your program, and then you run out of RAM, and it eats all your RAM, and your Java virtual machine crashes, and hopefully your computer doesn't crash, because that's the point of that's another benefit of a Java virtual machine, is it only has so much RAM, and when it runs out, the program crashes instead of crashing your computer. Whereas if you're using something else, it'd probably crash your computer. But nowadays we have so much memory, we don't really have to worry about it too much, especially with the programs we're going to be writing. So if you want to learn more about like what's behind the scenes or under the trunk of Java, I'm going to put a link in the description for some Cornell lecture notes that I Googled real quick and thought were interesting. And now the next thing I want to do is just go through sort of the first classic program, right? Hello World. And so let's do it. Vim foo.java. Vim is my text editor. This is the name of our file, or if you're in Eclipse or something, this will be the name of your class, foo, right? The .java extension is just the extension for Java source code files, which is the code that you write. Now, something to note, public class foo. Now, if you're in an IDE, it'll automatically generate this stuff for you, so you don't have to worry about it. But note that if you have a public class, it has to be the same name as your file. And in the lecture notes, it says why it has to be that way, so I'm not going to tell you. So let's go. Public static void main string args system dot out dot print line hello world, and save that. Now, if you don't know what any of this means, don't worry about it. I have a feeling I'm running a little long already on this video, so I'll explain it in the next video. I'll go line by line and see if I can't point out what everything means, and hopefully it all makes sense. So now I'm going to go ahead and compile it. Note that we only have one file in here. So Javac, I assume, stands for Java Compiler. I don't know if that's really what it stands for, but that's how you compile things. If you're in an IDE, you probably just press a little play button, or like a green triangle. Now notice we have two files. The .java is your code. The .class is the bytecode the compiler is just made. So now we can run it, foo, and voila, hello world. So this is like the first program. Yes, you're a programmer now. And because I'm on Linux and I'm awesome and I can pipe things together, I can run this program, pipe the output, which is hello world, into another program called cowsay, pipe the output of cowsay into a program called lolcat, and now I have a cow, a colored cow saying hello world. Oh, yes. Awesome. Don't worry about any of that. I don't know why I showed you that stuff anyways. So I'll see you in the next episode or whatever we're going to call it. And I'll go through and explain all of this stuff. Deuces.